5,
4,
3,
2,
1,
go.
Hello and welcome to Space Now, the space news podcast from the National Space Centre that goes beyond the headlines. I'm David Southworth.
And I'm Josh Barker.
We're science communicators here at the National Space Centre, and today we're going to be doing a slightly different kind of episode. Today we're going to be answering some of the questions that you've sent in. But first, let's do our space wows. Josh, have you got anything for us this week?
I have. Are you a fan of Thai food, David?
Yeah, I am. I love spicy food.
Excellent. In that case, space might be the place for you.
Okay, good to know.
I recently saw a news story this week that for the first time in history, food from Thailand is going to make its way into space.
Interesting.
So the Thai government and their food production departments and agencies have been working with NASA to get their chicken up to scratch and up to standard to send into space.
That sounds good. I understand astronauts do like to take quite spicy food to space because they don't taste quite so well, lots of mucus form, something like that.
Yeah, so definitely the flavours that you want to be able to clear so that you can get things tasting. So Thai curry, for example, which is on the menu now, is something that's there. But you're quite right, this food has to be really specially prepared so that it can go. It has to be of a certain quality, prepared in certain ways, packaged and treated, heat treated so there's no bacteria, so it doesn't go mouldy on the journey. And over the last few years, the Thai government, the Thai food agencies have been working with NASA to get their food up to standards to go into space, and in a couple of weeks' time it will be on board the space station ready for astronauts to eat.
That is fantastic. You're right, that would encourage me to go there. My space wow is a bit different from that. You asked me if I'm a fan of Thai food. Are you a fan of Austrian waltzes?
I can't say I've done many,
not so much.
But they can be interesting.
This was a news story I spotted. I believe it was right at the end of May. This was an orchestra in Vienna that beamed out into space a live recording of Johann Strauss's On the Beautiful Blue Danube. People might know that better as the theme tune or one of the main themes from 2001, the sci-fi film Kubrick, I think it was. The reason they did this, they beamed it in a specific area. They beamed it towards the Voyager 1 spacecraft because you're probably aware of the golden disc on the Voyager spacecrafts. That included, among other things, recordings of various representative types of music from Earth. And the Austrians felt it was a real omission that this very, very famous waltz wasn't on that golden disc. So they wanted to correct that by beaming it out towards Voyager 1, which I think is a nice touch.
Yeah, that's really exciting. Not the first time that music's been sent. I remember
Absolutely.
A few years ago the famous story of one of the Mars rovers singing Happy Birthday to itself on the surface. So yeah, it's cool to see that we're still spreading some of our culture out there.
Yeah, I like stuff like that. Right, I think maybe we should head into our mailbag and try and answer your questions. Josh and I have not seen the questions, so we're going to be picking them out at random, doing our best to answer them. Some of them I'm sure we will know more than others. We may have to put some aside, do some research and come back to them at a future date. But let's see how we go. Josh, do you want to take the first one or shall I?
I can take the first one. You usually ask me questions, so let's have a go. So, our first question is from David Menzies, thank you very much for your question, who asks, is there a north, south, east and west in space? What do you think? You got any insight into that, David?
Right, I suspect this might be the format of a few of these. I'll tell you what I think I know.
Excellent.
You can correct me.
Good start.
So I believe north, south, east and west on the Earth. North, obviously, North Pole, south is South Pole. Now I think north and south, which is kind of arbitrary anyway. And then we define east and west from those. Now, as far as I'm aware, we do still have a kind of a north in space. And I think it's based on the plane of the solar system. And when we talk about looking down on the sun, we say things orbit anti-clockwise. I think that's looking down at the north of the sun. So I think we do that same arbitrary thing of defining, certainly within the plane of the solar system, north on the sun in the same kind of way as we do on the Earth. Tell me where I'm wrong.
That's my understanding as well. I think it goes a little deeper than just sort of picking an up and down. So we use magnets in the magnetic field, the Earth, which is what gives us compass. Yeah. You use those to point the direction of north.
But then aren't the north and south poles of a magnet kind of arbitrary?
That bit's kind of arbitrary, yeah. But we have, I guess, a process that determines which way is up or north in this case. And yeah, you're quite right. We use a similar reference frame is generally the term we use to we call it out there in space. We want to keep things sort of working in the same way, and so we orient ourselves similar to once we were in space. We already had this established frame of how things worked with north and south and east and west on Earth, and then once we got into space, you're quite right, we started to do that, and we extend that beyond. So we use the sun and the solar system, and then we even now have a north and a south pole of things like galaxies that we have, just to give us that concept of keeping things the right way round.
Nice. So am I right in thinking that the galaxy and the solar system are broadly lined up, the disks are lined up? so that the north would be the same for both, or have I got that wrong?
I think our solar system is slightly tilted.
Okay.
So I don't think we quite match up that way. Not perfectly lined up, but it gives us a sort of an idea. And actually, once we get outside of our solar system, we start to have to give ourselves a reference point. So we'll say, north with respect to the Milky Way or whatever it might be.
Perfect.
And that's just ultimately isn't necessarily an absolute truth. So there isn't, as far as we're aware, but we've worked out a true up in the universe. But if we start to use the same sorts of ideas, it gives us ways to work. So one of my favourite examples of that is if you go to the space station, their up is simply away from the Earth.
Which makes perfect sense.
Yeah, it means that all the astronauts that are working know that down is the floor and is towards Earth, and it makes sure that everyone's sort of speaking the same language.
Because in microgravity, up and down is also kind of arbitrary. Yeah.
Yeah, and then it's made even worse by the fact they're going around the Earth.
Yes.
So at some points their up might be close to where we would consider north, but then 45 minutes later they're on the other side of the Earth, facing the opposite direction, and so you don't want to have to be changing what that is every time. Yeah. So you find these common ways.
It's away from the Earth.
Excellent. So maybe our next question.
Okay, this one is sent in by Mia. Do you have any sci-fi book recommendations? I'm going to pass that to you first because I'm not a huge sci-fi reader. Any recommendations for us?
There's a couple that I quite like. So a big one that I think is fairly common, especially as a story, is a book called The Martian. Recently got turned into a film. We've got a bit of a connection here at the Space Centre. We've got one of the artefacts from that film on display, which is one of my favourite artefacts. But I think that's a really nice exploration of what could the future of spaceflight be. It's set not too far in the future. The technology is kind of the same. It's not all Star Wars and spaceships and laser guns, but it gives, I think, quite a good, accurate sort of telling an experience that you might have as an astronaut. I think it's a little bit dramatised for the story, but I think it's a really good indicator of what that might be. So as a story, that's one that always resonates with me.
Yeah, I was going to talk about the ending, but we're probably best not to.
No spoilers.
While you're talking, I'm glad to let you go first, because I did think of one I did actually read relatively recently. Now I forget the author. I may look that up in a moment. It's called Orbital. I think it may be Samantha Harvey. I'm going to fact check myself in just a moment. It won the Booker Prize, I think, last year. Quite a short book. It's only 120 pages or so. And I'm not giving away much, I think, when I say not too much actually happens. But it's based on the International Space Station. It goes through a day. That's 24 hours, so 16 orbits of the International Space Station. And there's some fascinating, just what feels quite mundane reports of what it's like to be up in space. Lots of stuff about how the astronauts interact with each other, how they feel about missing their families on Earth, all that kind of thing going on, among a few events that may have greater significance as the book goes on. But yeah, that was a really interesting read.
It's interesting you've recommended that one, because at the risk of exposing myself and my big shelf of shame that I've not yet read, I was bought that for Christmas and it's not quite bubbled its way to the top of my reading pile yet.
I would
with that recommendation, maybe I'll bump it up a few now.
And as promised, I'm going to fact check myself in real time. Is it Samantha Harvey? Yes, it is. Fantastic. I remembered the author as well. So yeah, I think that's one recommendation from each of us.
Let's go to the next
one.
Your
turn, isn't it?
So let's have a little look. So this one's from Kyle Wood, and it says, is terraforming Mars using nuclear weapons a realistic and effective way of achieving this, or are there more effective ways of doing it?
Okay, maybe Matt Damon can help with this one from the film. Okay. Well, let me. I don't know a lot about this. Let me start by saying what I understand about terraforming. You might be able to give us more, and certainly I don't know how nuclear weapons might do that. So my understanding of terraforming anywhere, Mars is the place that's often kind of referred to, is that you're trying to make another planet or potentially a moon be more Earth-like, be livable for humans. So essentially what that means is doing things to try and create the right climate, most importantly to try and make an atmosphere that's breathable and livable in. So, as I say, I don't know the detail, but I know people have speculated about all kinds of ways you could create a thicker atmosphere on Mars. It has a very thin atmosphere, bring more oxygen into the atmosphere. I think their atmosphere has something under 0.2% oxygen.
Yeah, it's very thin.
21%. So you need to change the composition of the atmosphere, and obviously over a planet, it's half the size, half the diameter of Earth, but it's still a huge planet. That's a huge amount of chemical reactions or whatever you need to do to achieve that. That's about all I know. Josh, tell us if you know more.
I think that's a good start, yeah. So this idea of changing an environment to suit us, which is, something that we've thought about because we see that there are environments out in space. Many of them aren't suitable for us. And so if we're going to live there, we either build complex equipment to live in, or can we change the environment? But changing the environment's quite hard, which is something that I sometimes think is slightly interesting, because we talk about how our environment is changing nowadays. We're seeing the effects of the activities that we're having on the Earth.
Absolutely, all the climate change, the effects
adjusting
of
our environment.
Yes, of course,
and so we know that in principle is something that can happen. And so, looking at Mars is something that we've thought about doing. I don't know if nuclear weapons are the best way to do it.
Can you explain how nuclear weapons could be a way to do it? Because I don't even understand that.
I think the basis of that is essentially getting material into the atmosphere. So, for example, one of the sort of disaster scenarios we talk about, potential, if there was a nuclear war in the future, is that actually these huge explosions create a lot of material that can end up in the atmosphere, and that can perhaps block the amount of sunlight that comes through. Okay. If the atmosphere is thicker, it could trap heat in, which it can have some adjustments there.
So in principle, you could somehow, I'm not quite sure how, you control the effects of that and use that to amend, to change the environment in a way that we would want it to be.
Yeah, I think
with a nuclear reaction, is that possible, or is it just too much out of control?
I think it's probably got some possible. I think there is definitely, if you set off a load of nuclear weapons, there's probably something going to happen on a large scale. But I think you're quite right. I think it would be quite uncontrollable. Something like that has got quite negative side effects. You make everything radioactive, which, great, we've got a breathable atmosphere, but now we're bombarded with radiation and we're all very...
breathable as we might like.
Yeah, we're all very ill, and that's not a good thing. I have seen a couple of theories and suggestions that we could just go up and essentially build big factories and use similar processes that we've seen affect the atmosphere down here as a way to add material in to thicken it. And so I think there are some rough thoughts based on some of the activities we've done here. I think the big problem that we've seen with that is, first of all, it would take an enormous amount of time. Unfortunately, atmospheres don't change very quickly, which is why the rapid changes that we're seeing on Earth are quite concerning. It takes a long time to build those up. And also, we never know quite what the end goals are. And I think that's also the big concern, is that, we could perhaps, increase the thickness of the atmosphere, and that might be great over the next 50, 100 years, but what happens in 200 or 1,000? Are we going to stumble into a process that runs away with us, or it becomes uncontrolled? Yeah,
the long-term consequences of our actions have not necessarily been a strong point of the human race here on Earth, have they? So do we do the same thing on Mars? Maybe not.
It's difficult to predict, and we don't want to be in a situation where we are now, where we're looking back and thinking, well, if we'd have been a little bit more conservative, or if we'd changed our approach or done something earlier, we wouldn't be in a position we are now. And I think one thing we've become aware through environmental science and studying our climate and seeing how these things change is actually getting a greater appreciation for saying, well, these things can be, small changes can have long-term, long-lasting effects that we need to make sure we understand before we start going messing too hard.
So terraform is interesting because we want to have those effects, but we want to be able to control them, and controlling them in the long term is something we probably can't do very accurately.
Yeah, and ultimately, do we want to? Is there something, if we changed Mars from what it is now, it might benefit us, but does that benefit, other things in that situation? We're currently looking for life on the surface of Mars. We know it used to be very different, and changes have happened. We want to make sure that we don't irreversibly change something now that we're going to regret later.
Yeah, so I think our answer is we're not sure it's the best way. We're not even sure we should do it.
I don't think so, no.
Okay, my turn, I think.
Go on then, yeah.
Let's pick another one. Here we go. Oh, it's a long one. Okay, this one's from Jessica. When we look for alien life on other planets, why do we just look for planets that look like Earth? Couldn't alien life adapt to any planet, even if it doesn't look like ours? That's a really good question.
That's an excellent question.
I think
the basic, straightforward answer to that is that we look for life that looks like ours because we know it works. We know that when we look at Earth, we find water, and where we find water, we find life. And so if we know that a thing can exist given a set of circumstances, looking for those circumstances as a starting point, I think is a really good one.
Think of the kind of life that we recognise, that we understand. Because of course, I think the question's absolutely right, Jessica, you're spot on. Who knows what alien life's out there? It could rely on totally different things than we know. I think also part of it is when we're looking for exoplanets, so planets outside our solar system rather than within our solar system, it's very hard to see any real detail. So looking for the kind of things we expect to see in the Earth's atmosphere is kind of almost all we can do at this stage of, could this planet be a life-supporting planet? So we look for water vapour in the atmosphere, we look for oxygen, carbon dioxide, I think. And there was that news story recently, I forget the chemicals, I probably couldn't have told you even a minute after I'd heard the story. A couple of chemicals that on Earth I think we only see produced through organic processes through
yeah,
life.
that's typically how we do these searches. Is because we understand how life works on Earth so well. We've had many years and many experiments to study and understand that. We can find these things. You're quite right. These are what we often call life marker chemicals, things that we look for that are specific chemicals that don't usually hang around or don't exist without life being them. So
do you know the names of those two
I
chemicals?
can't remember the one off the top of my head.
I knew that'd be putting you on the spot.
One of my favourite go-to is oxygen. Oxygen's the big obvious one. That's because it's really reactive. Yeah. And so oxygen tends to get used up. It likes interacting with other chemicals.
I didn't know that. Okay.
Yeah, and so
if oxygen remains in an atmosphere, that suggests there's some sort of stability, some process that's producing
right.
it.
Something's producing it. Now we know there's loads of ways of producing oxygen that don't require life, but the fact that we see oxygen in an atmosphere means that there's some sort of churn. So the Earth, for example, it's trees, it's plants.
Yes.
They produce, a lot of the oxygen that we have. Algae in the ocean is replenishing all that oxygen. If all that went away, all the oxygen would disappear. We wouldn't see it in our environment, and we'd notice a bit more of a stable, less dynamic atmosphere.
I think also actually we've talked. Well, I brought up the subject of exoplanets, but even within our solar system, we're not just looking for life in. Well, there are no other planets that look quite like Earth. Ancient Mars, we think, was a bit like Earth, but even within our solar system, we're looking at. Not so much planets that look like Earth, but probably still processes for life to maybe evolve that look a bit like Earth. I'm thinking particularly of Europa. Some of the other icy moons as well. I know Enceladus is a moon of Saturn, which is a place people think there could be life. Because on those sort of planets, we think we know there's an icy surface, we think there's liquid water underneath, and people have speculated that there are hydrothermal vents, so sort of heat coming from inside those moons. And around hydrothermal vents on the ocean floor is where we think life may have started on Earth. So we're looking for not planets necessarily that look like Earth, but still processes that we recognise from Earth.
Yeah, exactly right. And it's just those things. If we know that certain things end up with what we want, then we look for those things. It's a good starting place. Now, it might not give us any results. Maybe we'll plumb the depths of Europa's oceans and find nothing but, some nice vents and
probably
that's it.
Quite likely, yeah.
Yeah, probably quite likely. But it's a good starting place. And we can say, well, we know that this makes it common and most likely, so let's search there because we have best chance of getting the results. If that doesn't work, maybe then we go a step deeper or we look at something a bit different. One of my great examples is Titan, the moon of Saturn, which has got a whole cycle like we have rain and weather down here on Earth, except it doesn't use water, it uses methane. Yeah. And so this idea that we've got this dynamic changing system of rain, evaporation and clouds and oceans and seas, well, could that lead to something being able to exist there that perhaps wouldn't survive on Earth in a similar condition that we have here, but gives us that environment there. So it's about finding a good starting point and then building off of that based on what we know.
And probably, to be honest, part of it is lack of imagination. We're looking for things that we recognise. What would we look for if we were looking for different forms of life? We don't know, and we can't really imagine what it is. I'm not sure we've given all the detail on that some space experts could, but I think we've done our best.
I think people build entire careers on trying to answer that exact question. Well. So if they can come up with any better answers to those, then get in touch because they'll be the scientists. Yeah. Okay, let's have a look at what the next question is. So here we've got one from Sandra. Sandra says, I don't understand what's happening with the Lunar Gateway. What was the original plan and has it now been scrapped? Why? Which is something we talked about recently.
You and I, in fact, we did that together, didn't we? We talked about the proposed NASA budget cuts and the effect on the Artemis program. I can't remember if we specifically mentioned the Lunar Gateway or not. Maybe we didn't.
I think we might have mentioned that it was one of the projects that was not going forward, but I think that was as far as we went. Again,
I'm going to take the option of me saying what little I know and you can correct me. So the Lunar Gateway, my understanding was it was going to be a space station orbiting the moon as part of the Artemis program. That was going to do a few things. It was going to be in quite an eccentric orbit, so going down quite close to the moon on one part of its orbit and then quite far away on the other side. So what the intention of that was that it would make it easier for human trips to land on the moon in the future, rather than that having to be all in one go with everything on board the rocket, everything, the lander and etc. You would be able to come and dock with a space station quite far out in space, which is an easier thing to do. And then as that space station orbits around, then you get much closer to the surface of the moon. You can go down from there on a shuttle or something that they've got on board.
Exactly right.
So that was the plan. Excellent. That's what I like to hear.
It's a good plan, I think. Yeah.
It was a very good plan. And yes, under the current proposals, the Trump administration's proposed budget, still proposed as we record this, that will be cut. So that's a shame, I think.
Yeah, it is a shame. And in fact, we just recently got a response from NASA in line with that proposal budget to say, if this was the budget that went ahead, this is what we do. And yeah, that has confirmed that this is a project that unfortunately they decided not to go ahead with, which, is a really big shame. The last few years, we've really sort of been gearing up to go back to the moon, to send people to the moon, but not only just to go and, have a fun little mission, but actually to really start having a longer presence on the moon, extended bases, and really exploring that environment, which is not something we've done much of.
Yeah, and the Gateway, I think, is a great example of what I found quite appealing about the Artemis program compared to maybe what went before. So the Apollo program in the 60s and 70s was very much about the space race, about beating the Russians to the moon. This time it felt like it was going to be a little bit more forward-looking, that yes, they wanted to take people back to the moon, but this time with a kind of long-term purpose. We want to build things like the Lunar Gateway, potentially establish a base on the moon, things that might help space exploration a bit further going into the future. And now, if these cutbacks do stick, it does feel a little bit more like another space race. This time, I think, with China is in Donald Trump's mind, but let's not go back to the politics of that. We've done that in a previous episode. Anything you want to add on that question about the Gateway?
I think you're right. It's all about that infrastructure. And I think what was really nice about Gateway was a bit like the space station, is that it was an international project. It was looking at saying, well, the space station has been in space for nearly 30 years now, and it's starting to show its age. It's still doing amazing work, but we want sort of the next generation, the next chapter. And Gateway was sort of de facto and kind of going to slot into that spot. It was going to be that next big international station, permanent place for people to go into space, easy access to the moon and potentially further. But the proposal's cutting that. And I think that's partly because there seems to be a readdress of focus. So NASA, under the current administration, seems to be more pushing towards Mars as the ultimate goal, rather than back to the moon. They want to sort of be the first to Mars. And so I think what we're seeing here is it's been determined that perhaps this focus on the moon is perhaps good and exciting, but actually it's not really what this administration wants their ultimate goal to be. Now, there's a whole heap of discussion that we did have about that, and that you could have about
could have more.
Where you position yourself. But I think that's ultimately what the plan is this shift of priorities.
Yeah. Okay, this one, this is a great question. This is a question from Ashika. Will Voyager 1 ever leave the galaxy?
Will Voyager 1 ever leave the galaxy? Well,
my initial reaction is yes. Is that true?
I think in theory it might do. So I guess for people at home, Voyager 1 was a probe that was launched in the 70s.
The one I talked about in
you
my
talked
space
about
now,
yes, exactly.
Perfect.
Back to space now. And the idea behind that probe was to investigate the outer planets of the solar system. Yeah. So to do a flyby of Jupiter and Uranus and Neptune, get some pictures, collect some data, but ultimately to end up on a path that would take it out of our solar system.
Yes, so which it has now done.
Yes, which it has done. So it did its mission and then it headed out. So at the moment, as we speak, it's hurtling through space outside of our solar system. Sort of, one of the furthest objects we've ever launched into space.
The furthest, I think.
I think, it's either that one or maybe Voyager 2.
I think it's Voyager 1.
A sister probe that was launched at the same time.
So will it leave the galaxy? I mean, like I said, my initial reaction was yes, because whatever direction it's going, it surely will eventually leave the galaxy. But while you were talking, I was thinking more about that. Depends which direction it's going, doesn't it?
I think that's the thing. I think there is mostly empty space. When we think about space, there's nothing there. And I think, initially, it's probably going to drift forever. But there are lots of other stars out there, lots of other solar systems that could affect it, capture its gravity. So I think it's probably likely that it might if we left it, unattended forever. Yeah. But there's always a chance that it gets captured by another star system and gets pulled into an orbit around an alien star.
Do you know which direction it's going? Relative to the frame of the galaxy. We talked about north and south of the galaxy, that's perfect as well. I think,
and this is where someone at home is going to fact check me, I'm wrong. Yeah. One of the probes, one of the Voyagers is going out along the galaxy, along the solar system, so in the sort of same direction, and one of them is going, I think, essentially down,
roughly perpendicular.
Or I can't remember, sort of away from that side.
So as long as they're not going towards the galactic centre, there's more density of stars and stuff in the galactic centre. So if we're going away from those, I think we're saying there's a pretty good chance both of those probes will leave the galaxy.
I think so, yeah.
When's it going to happen?
A long time. I mean,
it
took 50 years to get to the edge of our solar system.
So can we do the quick maths on this, or is it too complicated?
I think it's too complicated.
Maybe leave that for another episode.
I think you're looking at hundreds of thousands, if not millions of years,
I would
probably
guess well into the millions.
to get outside of our solar system. So a long time, and that's even if it does. I saw a really fun proposal for maybe we should recover it and bring it back to put it in a museum.
Well, that took a while. Well, I think maybe we should. That's a great question to finish on. A really interesting question, Ashika. Thank you. And I can feel myself being at risk of wanting to do some maths on the fly. And I think it's probably best for both for my pride and for the interest of our listeners and viewers that I don't do that. So let's call that a halt to the questions. So that brings us to the end of our first ever mailbag episode. I think that went okay, Josh.
Yeah, it was really fun. It was really nice to hear what our listeners are interested in.
Yeah, some really good questions. Thank you so much for sending those in. And of course, please send in more. You can send those in to podcast@spacecentre.co.uk. We will certainly be doing more of these episodes and we'll look forward to them.
And you can send other stuff in as well. So I want to give a little shout out before we finish to Sonia, who sent in some of her astrophotography. So she turned her camera up to photograph the things that were happening up in space. And she did a wonderful time lapse of the moon over the course of a month. So showing the changing phases and shapes that I'm sure you and I teach all sorts of children about across this way. So yeah, that was really nice to see. And she also put in a brilliant clip of a set of clips of the partial eclipse that people saw as well. So hopefully people are seeing that. If you're watching and if you're listening, check out the podcast description for the link to that.
So yeah, please do send in things like that as well. We'd love to hear and see anything like that. That's all we have time for on this mailbag episode. Please join us again next time.